Hello, thanks for tuning in and welcome to our last live stream of 2024. So great to see you all here and let me know in a chat where you're tuning in from. So eager to hear where all you guys and girls hang around. This is us looking at the third challenge of Advent of Spin 2024. Um, so the idea is to, read through the challenge and then solve the challenge live on stream before we release the fourth and last challenge of Advent of Spin for this year. Quick update. So we will solve the fourth challenge in January, so 6th of January. That's where the next live stream is scheduled. So mark your calendars and obviously subscribe and hit that bell to get notified once we go live. Alrighty, let me bring up my screen a little quick. So where is it? There we go. So now we are basically looking at the root of the Advent of Spin repository over on GitHub. If you haven't participated yet, let me bring in the URL as well. So this is github.com/Fermyon/advent of spin. This is where you basically can find all the challenges, not just challenges from 2024, also the challenges from previous years. And yeah, so with that, let's jump right into the third challenge. So we go to the 2024 folder, and over there we can find the challenge 3. So all challenges, share like a common introduction. Let me quickly skip over that because we are basically interested in the spec that lays out what we, oops, that was the wrong key. So that actually tells us what we have to do to solve that challenge. So let me quickly read through the story and to get everybody on track. So Santa leaned back in his favorite chair, staring at the flickering glow of the fireplace in the North Pole's main workshop. Around him, elves hustled and bustled, checking the latest data from their newly developed app. The wishlist management system had been a lifesaver, keeping track of every child's hopes and dreams in one place. The Naughty or Nice scoring system had streamlined Santa's toughest decision making, yet something still felt off. Even with all these tech, picking the right gift is harder than ever, Santa said with a sigh. We have the wish list, but what about those kids who don't write exactly what they want? Or the ones who list everything? The elf paused. The elves paused, gazing at each other nervously. No one had an answer until Matt, the head elf, stepped forward. Santa, Matt began, adjusting his green hat. What if we could use AI to help us? What if we take the name, age, and likes of a child and use that data to generate tailored gift ideas? Santa raised his eyebrows. AI? Isn't that a bit futuristic for us? Matt chuckled. Not at all. With the Spin SDK, we can make something magical. The AI could suggest gifts based on each child's unique profile. It won't replace us, it'll help us make better decisions. Every gift will feel personal and perfect. The workshop grew quiet as the elves considered the idea. Then Radu, Santa's most trusted advisor, spoke up. It's brilliant, Santa. With wishlist management and naughty or nice scoring already in place, this could tie everything together. Plus, we'd have more time to focus on building and crafting the gifts. Santa's face softened and a warm smile spread across his lips. Matt, you might be onto something. If this can bring more joy to children, it's worth a try. Let's make it happen. And with that, the third feature request for Santa's new app was set in stone. So this is basically the story. It's all about adding a new feature to Santa's app, as we already did in the previous streams. Let me quickly take a look at the chat. All right. So it's all about, using serverless AI capabilities provided through Fermyon Cloud, and we can use the Spin SDK to, make our code interact with a large language model. Backend requirements. In this challenge, you will deepen your knowledge of Spin component dependencies. Let's begin by exploring the gift suggestion generator WASM component. So again, as we did for the second challenge, we are asked to use Spin component dependencies. Gift suggestion generator WASM component. Implement the gift suggestion generator WASM component using Python. So last week we used JavaScript, right? So this week we will use Python to interact with serverless AI. Since you already created a WASM component during the second challenge, Santa's Python champion Alves Karthik and Joel have prepared an excellent template to jumpstart your development. Oh, this is great. So we don't have to start from scratch. Check out the .template folder here on GitHub. So within the challenge 3, there is a template folder, and we'll look at that in a second. The template provides a WIT world and a Python module. Let's check this. So there's a WIT folder, there's a WIT world, and there's a app py. Okay. Additionally, the Spin SDK for Python is already added as a dependency. All you have to do is to activate the virtual environment for Python, come up with a creative prompt, and use the AI inferencing APIs provided by the Spin SDK for Python. Once you're done with implementing your WASM component, use componentize.py. Componentize command, exact flags and args are documented in the README, and this is also, it's also pointing to the README file within that template. So this one, I guess, located within the template to compile your code down into WASM component. All right, let's tackle that. So first, let's explore what we got. So we got a WIT world. Okay, again, we have a package declaration. Then we have our gift suggestions generator world, which exports. So this component is designed to provide a capability, right? It exports the generator interface, and the generator interface has a suggestions record or structure with a name and suggestions. I guess that's the response value, and a suggest function. Yeah, it takes in a name, age, and the likes of that particular child, and that returns in, if not trapping, so if not, running into an issue, we return a suggestion or otherwise the error as a string. All right, let's sneak into this one. Okay, so we got a Python script that gives us the, let's say, basic structure, and we have requirements txt that specifies dependencies. Cool. So let's how can we grab this? Oh, I think we could maybe go one level up over here. No, can we download that folder? Is that smart enough? No, it isn't. So instead of curling we can basically, can I get a raw URL over there? There we go. So this is the app py. And let's go to, so in the previous, if you haven't watched the previous videos, so I live coded all the different challenges, right? And this is also on GitHub. So let me give you git remote --v. This is on github.com/Thorsten Hans. /advent-of-spin-2024. And this is basically where we will add like the gift suggestions WASM component. And I expect us to, update our spin app itself also along this string. So let's go into WASM components. So we have the naughty or nice component that we created as part of challenge 2. And let's create a new one. Let's make here, how was that called in the repo? It was called gift suggestion component. Was in that one? So gift suggestion component. All right, let's go into that folder and let's wget this one. So we have the app py already there. That's good. And then next we need the requirements txt. Wget this one. Then we must create a wit folder. Could have simply cloned the repo, right? And in wit, we have the wit word raw file representation. Let's copy that URL and wget that one. All right. Cool. So we are asked to create a virtual environment. I have installed Python on my machine. That should be Python 3, what is it, -m vn. Create a new virtual environment, and now we have to activate the virtual environment. Okay, so there we are. We are in our virtual environment. Now we have that requirements txt, and we want to use pip to install all the requirements mentioned in requirements.txt. But let's have a look at what does the README? Oh yeah, the README file guides. If you haven't used Python so far, it lists like the prerequisites like Python 3, 13.0. And then, yeah, it basically explains how you can use how you work with Python virtual environments. And there's a link to the official Python documentation. Cool. So we already activated this one. And now we want to install the dependencies listed in the requirements.txt. That's great. So let's use pip install from the requirements.txt file. There we go. Okay, my pip is not the latest, but that should be good. So installed collected packages. Yeah, there we are. Cool. Use componentize py to regenerate Python bindings. Yeah, Python bindings are great, which means we will end up with IntelliSense, right? So let's open up this in Visual Studio right now. And let's see, there is a comment that we can import in the LLM capabilities from the Spin SDK. Let's see, LLM. And we can do inferring over here. Cool. So we have to provide the name of the model. And if you follow, the Spin documentation or in the context of large language models and serverless AI, you will figure out that you can use Llama to chat, for example. And we have to come up with a prompt. So let's build our prompt. Our prompt will be a multi-line string, like this. So depending on for every large language model you interact with, you may, have to use a different schema or format for the overall prompt. So for Llama to chat, what works super nice is first defining like the system prompt, and we may end up adding like additional instructions. But last but not least, we will have the user input, right? So the user input is something along the lines, create gift suggestions for, and we have name, age, and so on in context over here for name, who is age years old and likes. Cool, that's user prompt. So for the sys prompt, say, let's give it like an identity. Yeah, that's right. We need a name for elf. Here to me, one of centers elves. His elves. I think that's okay. We can always work on a prompt, right? Let me. One of centers elves. This is good. This is good. This is good. Come up with up to 5 gift suggestions. Take the age and the likes of the child in context. Okay, so this is more than enough for a simple system prompt, right? Cool. So we use that prompt. We pass that to infer. So there's also infer. I think it's infer with options. Okay, and this one takes inferencing params. So let's specify that as well. Let's say params equals inferencing LLM dot inferencing params. Is it like this? It is not like this. How to create a new instance of that? It's like this. Okay. Okay, so we can specify max tokens, and let's say let's go with 300. Repeat penalty is default 1.1. Let's stick with that. Repeat penalty token count is, let's also stick with the default over here. Temperature. So this is pretty high by default. Let's start by setting the temperature to 0.4. So as closer as we go to 0, the stricter or the less is the large language model allowed to make up. Yeah, I think for top K and top P, we also stick with the default values. 0.9. Okay. Can we make this nice? I don't know if I have a formatter installed. Is there a formatter somewhere? Let's check. 12.2 millions. Let's give that a try. Okay. P format document. Okay, it does not act as a formatter. Great. Would prefer an indentation like this, to be honest. All right, so with infer with options gives us an inferencing result. Okay, so let's say res equals that. And if we look at res, what's over here? Yeah, that's wrong. So the result gives us the text, which is obviously the answer the LLM came up with. And usage is basic, token usage information. So how many tokens were generated and how many tokens were consumed by our prompt. Maybe we want to use that later on, but for now, we are good with just taking this as it is. Okay, so our task is to return, as you can see, if we hover over the suggest method, suggestions. Okay, so let's say return suggestions. Okay, and we have the name that's basically passed into the method, and we have rest.text as our suggestions. Okay, so this is it. I guess we are done with implementing our gift suggestion logic. Okay, let's have a look at what we can do next. Use componentized.py to compile your source code down to WebAssembly. Componentized.py -d. Okay, we point to the wit folder. We say -w. I assume that's the word. Right, let's check if we go to our implementation, search for this string. Yeah, that's the word name. Okay. Then we ask componentized.py to create a component. Okay. And then we have a -m flag. We have to look up what that basically means, but yeah, I assume that's just telling the compiler, hey, by the way, we are using Spin SDK as a third-party dependency from the point of view of our app, of our WASM module, and to ensure it will be imported, and we specify the output to be gift suggestions generator.wasm. Okay, let's copy that one. Go to terminal and let's try. Component built successfully. There we are. Alrighty, cool. So we implemented our component. Let's go back to a challenge. This readme, sorry. Okay, so the elves expect a new HTTP API endpoint at API/generate gift suggestions. Okay, let's copy that. Accepting post requests. To receive meaningful gift suggestions, they will send JSON objects using the following schema as a request payload: name, age, and likes, and basically what we just pass into our Python WebAssembly component. Again, the elves want you to use Rust for implementing the spin component. If you completed the second challenge, you may remember that Michelle gave amazing tips. If you haven't looked into the second challenge, consider at least reading the specs of the challenge. Yeah, that's right. So Michelle gave some amazing tips on how to get started with, building or implementing spin apps using Rust, and which templates you should use, and pointing to proper pages of the spin documentation to get you started. Now it's time to integrate the gift suggestions generator WASM component you built in the previous. Okay, so first let's take care of implementing our HTTP API endpoint. Generate gift suggestions. Okay, let's go 3 folders up. And as you can see, I had a naming pattern in place, so it's API - whatever we are asked to do. So we again do a spin add over here to add a new component. We select HTTP Rust and we call it API gift suggestions, right? We skip the description for now, and this one should basically, we can make it work just with that hard-coded. So we don't have to pass /3 dots at the end of the HTTP path. If that's the case, so specified like this, our component will only be invoked or instantiated and executed for requests exactly with that URL, meaning we only have to check for the HTTP method. Cool. So let me first clean up my spin.toml file, because adding an additional component, so we end up with all the new configuration aspects for that component at the bottom of the file. However, I prefer to have it over here, at least a trigger, right? Oh, and I misspelled that one. My mistake, sorry. So easy fix is, instead of going down the rabbit hole and renaming everything, it's just doing a spin. Add again, HTTP API gift suggestions. Yes. Oh no. The route path, there we go. That is still in clipboard. Cool. So let's check. Gift suggestions. Yeah, this is better. This is better. Okay, so let's move the trigger, where all the other triggers are. Let's rearrange this a little bit like this. This looks good. Okay. Cool. Let's have a look at the implementation, but I will open up a new instance of code to do that. Because, language server is happier if you open that crate as the root folder. All right. So if we don't have to use the router for that one because, it's only triggered if the URL is correct. So all we have to do is to check, let's say, match request dot. Why don't I have IntelliSense over here? Request. Let's return it to do. This should at least give me. Okay, this should make the REST analyzer happy. So now if I take a look at the request, I could see the method. Okay, so I can match on the method, and only if the method is referenced to method post. This one. Oops, that's weird. Then I want to handle the request. And for all others, I want to simply return, okay, response new, what is it, 405? I think it's 405. Now the status quo. I think it's 405, or it's 415. No, method not allowed. That's correct. Okay, so 405 if the request is not a post request. If it is a post request, what do we want to do? So the elf send us name, age, and likes. Okay, so we say we have a pub struct request model, name string, age, what was it, U8, and likes is also a string. And this is a uppercase. There we go. Next, let's say we want to obviously use 30 JSON to serialize, deserialize into different structs. So cargo add 30 with derived capabilities, cargo add 30 underscore JSON. There we go. So let's derive from deserialize. What's over here? Yeah, sure. Because, for reasons, that's right. Cool. So, okay, let's try 30 JSON from slice request body. And we could say let model equal to this, else we say, so now we need to specify turbofish syntax over here to request model So now 30JSON knows, hey, try to deserialize the request body into an instance of the request model struct. If that works as expected, we end up with the model in place. If not, we can use, let else, and then we go into the else branch, which is like, I prefer that because that makes my, the happy path on the left-hand side, and only, exceptions or only unwanted behavior goes or is indented. Okay. So if this happens, we want to return okay with response new for invalid payload provided, something along those lines. Or here we can say method not supported. Okay, so with our model in hand, we would want to call the Python component. And I guess that's what the challenge asks us to do. Now it's time to integrate the gift suggestion generator WASM component you built in the previous section using spin component dependencies and call the suggest function exported by the component. Cool. Let's check. We are over here. Let's go in this code instance where we have the spin tunnel in place. So this, so we have our WASM components. So we can do a spin at wasm-components, then it is gift suggestions like this. Cool. We want to import this world. Yes, the advent of spin world or package. Sorry, not world. Select one or all. Yeah, we want the generator interface, and we want to add that to the gift suggestions spin component, right? There we go. Worked. Let's go to the other Visual Studio instance because I expect something. Oh, we have to generate the bindings, right? Spin depths generate bindings language Rust output. Okay, we have to specify the output. Oh, let's simply customize that. Gift suggestions, and this is gift suggestions as well. Bindings generated. Okay. You need to add with bind gen create. Oh, we did that before. Yeah. So we copy the git the cargo add command over here. And now we go back to the Visual Studio Code instance for our API gift suggestions. Now we have a bindings folder over there with tabs and mod. Okay. Before bringing that into context by adding a mod declaration in lib.rs, we add with bind gen as we were asked to do. And the final step would be to add a mod bindings declaration over here. Cool. Now let's check what we have. Bindings, steps. So we have exports. I would expect, maybe we have the generator. There we go. This is what we want. And we have the suggest method, and we pass in model.name as stir. We can pass in model.age. This is U8, implements a copy trait, so Rust will simply copy the value, and likes again as a string. So we can again say model.likes as stir. Okay, once now it is, we are not returning yet, capturing the return value. let result equals that. Oh, this is a method call, obviously. Does it make a difference? Like this, okay. All right, so now we have our result. Let's go back to our instructions. WebAssembly has a deny by default capability-based security model. As your WASM component wants to interact with a large language model, you must allow your spin component access to an AI model and configure the component dependency to inherit these permissions. This is new due to spin component dependencies. Hint. Center's elves were pretty confident that Llama 2 chat, okay, could be a good LM. Yeah, we choose Llama 2 chat before. They also mentioned that Spin 3.0.0 introduced a breaking change when doing local AI inferencing. Model files have a different location now and gave us this link, okay? The elves will try to invoke, oh, this is also important for, ensuring that we return, like a proper result. So name and gift suggestions. Okay, so we have to do a small transformation over here. Let's say pub struct response model. So name is string, and gift suggestions is also a string, right? Cool. So we say this one is derive serialize. And we have to use serd rename over here because we want that in this name. Because by default, the serd will use the name of the property. However, Rust Analyzer will not be happy if we use camel casing for defining our fields, struct fields. So serd has a rename macro that you can place on struct fields and instruct it how that should be named in our case when using serd JSON. Cool. I'm a fan of implementing the first. Let's implement the from trade. We can implement it so we get back. What is it? Oh, that's a result of suggestion. Yeah, let's use the question mark operator over here. So we end up with suggestions. So we implement from suggestions for response model. Okay, so we, the suggestions instance is passed into the from method, and we have to construct a new instance of the response model. So we can simply say self name as value dot name, and this is value dot suggestions, and obviously we have to clone those. We have to clone this as well because it's a string. And let's implement another trait. Let's implement, and I think I've done that before in one of the earlier challenges as well. Let's implement the into body for response model, because that will streamline our API when actually constructing the response. So we can say serd JSON to vec of self. Oh, that one, I think, yeah, that's good. This could fail, but I think we can simply unwrap it here. Yeah, that's because that's the implicit result return value right now. Okay, so we have the result. We say response model. Let's call that, let's rename this one result equals response model from, and now we can pass in the infer. Okay. Finally, you can say, okay, response builder new 200. And there was another, I guess, yeah, we are asked to set the content type header to application JSON, content dash type, application forward slash JSON. All right. This one fails because it's lacking. Oh, what was that? It was with context, right? With context. Or creating suggestions. Like this. And I think we have to bring use anyhow. Should make it heavy, doesn't it? Huh. Oh, I see. Yeah, I see. Okay, we can simply say unwrap, which is basically resulting in, us, the happy path still works, and then we will fail if our welcome component will run into an error. Okay, so we have the header set. Let's set the body to result, and let's call the build method. And we have to return explicitly over here, and then we can remove that one. All right, looks good. I mean, obviously it's not happy with this, but now it's happy. Now it's happy. Okay, so the instruction also mentioned WebAssembly is denied by default, and we must configure the component dependency to inherit the permissions. Yeah. So by default, right? Guest code or your spin app is not allowed to interact with external resources, and a large language model is such a resource, right? So we go to our spin.toml file and we scroll down, try to find our gift suggestions component. Okay, so AI models is what we want to whitelist, and we want to whitelist the Llama 2 chat model. Now we have to take care of inheriting or ensure that all the WebAssembly, all the dependencies receive the same permissions, right? So I already did some Googling, and in the documentation of how you can use component dependencies, there is also dependency permissions. By default, dependencies do not have access to spin resources that require permission to be given in the manifest, like network hosts, key value stores, SQLite databases, variables, etc. If a component has a dependency which requires resource access, you can grant it by setting the dependency inherit configuration flag in the spin component manifest. So on the scope of our component, we basically set this. Cool. Let's try that. So we are in the scope of our component, and we do that. Cool. So I would say let's build that spin B. Okay, build was successful. So instead of setting up the large language models on my machine, I will use the Cloud GPU plugin. Let me quickly spin Cloud GPU plugin. This one. So this is basically a plugin that deploys like a proxy or an API to your Fermyon cloud account. And when you do AI inferencing, instead of bootstrapping the module on the large language model on your machine, you can leverage like the beefy GPUs that we have in Fermyon Cloud and that you can also use as part of the free tier. So I have already installed the plugin with Spin CLI. I mean, it's like, let me check. So if you do a Spin plugins update, you can do a Spin plugins list, and I simply grab for cloud right now. So you see there's a cloud, we will see there's a cloud plugin, and there's also a cloud GPU plugin that I have installed on my machine already, which gives me access to the Spin Cloud GPU command. And there you can see we have destroy help in it and rotate token. Okay, so let's do Spin Cloud GPU init to deploy that API endpoint to my Fermyon Cloud account. And this will take a minute, but we will end up with a configuration snippet. There we go. That we can use for AI inferencing. And let's go back to VS Code for a second. And let's call that cloud.toml. We paste this in, and now we have to replace the URL with the URL displayed in Fermyon Cloud. Okay, so we go to cloud.fermyon.com, and there we should see somewhere the Fermyon Cloud GPU. So I copy this URL, copy link address, paste that in over here. That's it, right? So all I have to do right now in order to test it is basically saying spin up and provide my runtime config file. And I think you called it cloud. Yeah, cloud.com. Yeah, and we're already seeing using runtime config LLM compute remote HTTP. Awesome. So let's grab this one. Let's open up a new terminal. Let's do it in Postman. Come on, it's easier to come up with this, and that is local host 3000 / and we want to send a post request, and we want to send JSON with we have a name and age, and we have likes. Okay. Let's say, let's test for myself, right? Boston, let's say 22 likes. Mechanical keyboards. And what else? Mountain biking. Well, I would call it football, but let's go with soccer. Okay, so this should right now, send the request to our Spin app running on the local host, and the Spin app itself will take the object construct or call into the WASM component, and the WASM component will use the Spin SDK. However, instead of asking a large language model that runs on our own hardware, we will hand off the inferencing work to Fermyon Cloud. Fingers crossed, and let's hit the send button. What's that? Oh yeah, wrong URL. That was an error 40. Error 40. This is basically the URL we want to use. Let's copy that. And again, fingers crossed. There we go. Invalid payload name. Oh yeah, H is obviously not a string. Okay, so this is already working as expected. If we provide a wrong payload, we will end up with a bad request. That's good. And now we are waiting for the large language model to respond. There we go. Oh, we got a response with emojis. Ho, ho, ho. I mean, you, okay. I got some great gift ideas for Torsten. A high-end mechanical keyboard with customizable backlighting and macro keys. A top-of-the-line mountain bike with a lightweight frame and advanced suspension, a soccer ball with unique design or technology, such as a ball that glows in the dark, okay, or has a built-in tracking device. Nice. Never had that. A gift card to a local bike shop. Oh, I would love that one. Or an outdoor gear store. So Torsten can choose his own adventure. A subscription to a mechanical keyboard or soccer enthusiast community so Torsten can connect with like-minded fans and stay up to date on the latest year-end trends. Ho, ho, ho. I hope the gift ideas inspire you to find the perfect present for Torsten. Okay, so overall, I mean, there is room for improvement, right? We could be a little bit more precise in which how the LLM should respond to our ask, but we get gift suggestions, right? Cool. We already saw that in the case of sending a malformatted payload, we get back an HTTP 400, which addresses additionally the helps will send malformatted requests to your API generate gift suggestion endpoint and expect a response with the status code set to 400. Okay. Awesome. And with that, we are done with the backend requirements. Next is front-end work. Add a new view or page to the front-end you created as part of challenge 1, allowing Santa and his elves to enter the name, age, and likes or interests of a particular person and invoke the gift suggestions API you added to the backend before. The elves will, again, they will check if the front-end is there. Okay. Let's get that done as well. So there is I guess it's in the front end. Yeah. Okay. So we can say ng generate service gift suggestions. And we can say ng generate component gift suggestions. Okay, let's open up this in code again. And again, front end is not my discipline, so let's copy over again the vast majority of HTML from over here, and we also could bring those into scope. That's over here. Import this from @Angular, import this from @Angular. So HTML, we say here, gift suggestions, and let's add some gears. Oh, wasn't there another? Let's go with it. Let's roll with that. All right, there we go. So we have a name. Cool. Provide your name. Then let's say H. Input type number. Min is 1. Max is, let's say, 130. This is H. H. And oh yeah, we had a text area. That's nice. So we can keep likes. Let's go 3. Label for likes. Let's say likes. Min length 3 is cool. We have a submit button and we want to have another text area. Outside of the form. Oh, let's do it like this. Yeah, it's smarter to do it like this. Okay. Five rows. Oops. Read only. I don't want to overcomplicate the front end, right? So let's keep it as simple as possible over here. This looks good. Let's go to our component and let's say we have protected string name string. Is it like this? I thought it was like this. Protected name string equals, okay. This. Okay. Protected age number equals. Let's stick with 10 by default. Protected likes string and protected suggestions. Okay. Then we need our, basically we can copy the entire implementation over here, bring that in and replace this. This is not a wishlist service, it's the gift suggestions service. And that's the gift suggestions service. And we can use the Angular router. No, we don't want to. So that was a special requirement from the wishlist UI created. If name length lower than and likes, yeah, we don't want to process bad requests. We can simplify this by saying suggestions suggest just for name. Oh, this name, this age, and this likes. And we get back the suggestion. So we have to create a new model. Suggestion. So we get a name and a gift. Was it suggestion or suggestions? Suggestions. Okay. Too many Visual Studios already. And this is also a string. Okay. Basically, we simply set let's implement suggest on our suggestions service, or we can copy that as well from there. So we have suggest method that takes a name of string, that takes age of number, And that takes likes, which is also a string, and it returns this, right? Now we have to bring up Sobel into context as well. And this is a post request. Yeah, post wants to have the URL and the body. So the API endpoint, we had that as well. Where is the VS Code instance? Oh, let's close this one. Let's close this one as well. So the API endpoint is this. Right? And our payload is basically name equals name, age equals age, and likes equals likes. This is it. And cool. Next, we have to add our path. So they are testing for what? Gift suggestions. Okay. Component gift suggestion component. The final step is we have to add it to the navigation. So I think it is in the app component. Let's add a new link and let's say gift suggestions. Gift suggestion. All right. I forgot something. I hope not. Let's go one up and let's do a spin build again. Compiling the front end. Already compiled the backend. We made no changes, so that was a quick one. So let's do a spin up. Now we should be able to open this. There we go. Gift suggestions. All right, we can put in the name Thorsten 42, and I like mountain biking and soccer. Okay, there's room for improvement. We could obviously disable this one and show a progress bar, but we see gift suggestion number 1, a brand new mountain bike with top-of-the-line components and sleek design, perfect for Thorsten's love of mountain biking. Gift suggestion 2, a state-of-the-art soccer ball with advanced technology that will enhance Thorsten's gameplay and the accuracy on the field. Oh, this would be like my teammates would, like, they will be laughing pretty loud. That's good. A gift card for Thorsten. Yeah. So we got a bunch of recommendations, and yes, there is room for improvement to make the UI nicer, and make it more like self-explaining and meaningful. I think let's double check. Let's double check. We are done, right? We can test it. Yeah, true. We grab the test file, raw. So the app is still running, right? Yeah, the app is still running. Let's go to VS Code that is opened over here. So I have a tests folder, right? So let me go to bring that up a little bit and bump the fonts a little bit. So like this. Let's go into CD tests. Let's wget this and let's move test.spa because I have a different naming schema in my repository. Finally, we can say her test c3.her. And let's see. Oh, that's actually doing inferencing. That's why it's taking so long. Yeah, there we go. There we go. This is great. Okay, let's go to the to this one. First, let me do a quick spin cloud GPU rotate token. Yes, and let me put that to /dev to get a new auth token, because I was presenting the token, I had it on screen. Let's remove the cloud toml file before committing, because although the token is gone. Okay, let's check what happened if I do a spin add dot drive. I guess. Oh no, that's good. Does the template for challenge 3 come with git ignore? Nice. Yeah, cool. Let's go to this is almost good. There's the .wasm file, and I don't want the .wasm file. Touch, no, echo .wasm into git ignore. Did I make a mistake? No. Do I have to prefix that? Oh, okay. So now we're talking. Cool. Let's add this. Let's git add dot git commit. All right. So now that everything is live again, and me at least put the URL to my solution again in chat. So there we go. And with that, there's only one thing missing, which is releasing the fourth and final challenge of Advent of Spin. Let's check. We go to github.com Fermyon Advent of Spin, and there is challenge 4, which is special. I don't want to spoiler. Look into challenge 4. I mean, you have you have 2 weeks basically to complete this challenge. It's not that demanding as previous challenges were. I hope you had, fun participating in Advent of Spin. And with that, Merry Christmas and Happy New Year. See you all in 2025. Bye-bye.